Hi everyone, and welcome back to Simple Understanding Channel. I'm excited to have you here for our CLTD Certified in Logistics, Transportation, and Distribution Preparation course. This is another module of the 9-module series, and I hope you're enjoying the journey so far. To make your studies easier, I've put together some great resources that you can download from the description below. First, a 600-plus page comprehensive ebook guide that covers every aspect of CLTD, from foundational logistics principles to advanced strategies. Packed with real-world examples, case studies, and insights from leading companies, this resource provides the depth you need to master the curriculum. Second, practice with 2,500 questions, covering both theoretical and scenario-based topics. Each question includes a detailed answer explanation, helping you grasp core concepts and practical applications. Third, access 1,850 flashcards with essential terms and definitions, organized by module for quick reviews and easy reinforcement of key concepts. This study package provides everything you need to excel in CLTD, from comprehensive content explanations to practical test-taking strategies. If you find this video helpful, please like, comment, share, and don't forget to subscribe to the channel for more videos like this. Be sure to check out the CLTD playlist for the previous modules and stay tuned for the upcoming ones. Are you ready? Let's get started. Module 8, Transportation, which consists with 8 different sections, which are Section A, Transportation Fundamentals. Section B, Road Transportation. Section C, Rail Transportation. Section D, Air Transport. Section E, Ocean and Inland Waterway Transportation. Section F, Intermodal and Other Transportation Modes. Section G, Transportation Management. Section H, Transportation Administration. Let's begin with Section Transportation Fundamentals. Overview. Transportation is the backbone of supply chains, ensuring the seamless movement of goods from suppliers to consumers. It influences efficiency, cost, and service levels, making strategic transportation management critical for business success. Different modes, cost structures, and lead times affect supply chain performance. Global trade relies on efficient transportation networks, making regulatory compliance and sustainability essential considerations. Freight consolidation, risk management, and technology-driven optimizations enhance operational efficiency. Infrastructure investments and intermodal hubs streamline logistics networks. E-commerce growth reshapes last-mile delivery, while disruptions like weather events and geopolitical issues challenge supply chain resilience. Effective transportation planning ensures cost control, service reliability, and sustainability, supporting long-term supply chain success. Key topics. 1. Role of transportation in supply chains. Explanation. Transportation enables the movement of goods within supply chains, impacting efficiency, cost, and service reliability. It connects suppliers, manufacturers, distributors, and customers, ensuring timely deliveries and inventory flow while balancing speed and cost-effectiveness. Real company example. Amazon's advanced logistics network integrates multiple transportation modes to ensure rapid deliveries, optimizing supply chain efficiency and reducing costs through strategic carrier selection and warehouse proximity to demand centers. Expansion. Companies enhance transportation efficiency through AI-driven route optimization, predictive analytics, and dynamic inventory allocation. Integrating real-time tracking and automated scheduling improves on-time performance, reducing bottlenecks and optimizing network efficiency for cost-effective logistics. 2. Modes of transportation. Explanation. Transportation modes include road, rail, air, ocean, and intermodal transport. Each offers distinct advantages based on cost, speed, capacity, and accessibility, allowing businesses to tailor logistics strategies to operational needs. Real company example. FedEx leverages a multimodal approach, combining air and ground transportation for express deliveries. This strategy balances cost and speed, enabling efficient supply chain operations and reliable global shipments. Expansion. Companies integrate intermodal solutions, leveraging digital freight platforms and AI-powered logistics planning. Optimizing mode selection based on real-time demand and cost analysis enhances operational flexibility, reducing transit times and improving cost effectiveness. 3. Transportation costs and pricing models. Explanation. Transportation costs consist of freight rates, fuel surcharges, tariffs, and handling fees. Pricing models include contract rates, spot market pricing, and volume-based discounts, impacting overall supply chain costs. Real company example. Walmart negotiates long-term freight contracts to stabilize transportation costs, leveraging economies of scale to secure lower rates while maintaining supply chain reliability. Expansion. Businesses use AI-driven cost modeling to forecast expenses and optimize carrier selection. Dynamic pricing strategies and fuel-efficient routing further enhance cost control while maintaining service levels across diverse logistics networks. 4. Lead time and transit time considerations. Explanation. Lead and transit times influence inventory levels, order fulfillment, and service reliability. Faster transit reduces stockouts, but may increase costs, requiring businesses to balance speed and efficiency. Real company example. Maersk optimizes ocean freight schedules to minimize lead times, aligning shipments with inventory planning to enhance supply chain responsiveness and cost-effectiveness. Expansion. AI-driven demand forecasting and real-time tracking enable companies to predict delays and adjust inventory buffers dynamically. Smart logistics solutions optimize transit time strategies, improving operational agility and customer service levels. 5. Globalization and its impact on transportation. Explanation. International trade depends on efficient transportation networks, influenced by regulatory policies, emerging markets, and shifting trade routes. Globalization increases demand for multimodal logistics solutions to manage complex supply chains. Real company example. Alibaba's global logistics network streamlines international trade, integrating ocean, air, and rail freight to optimize cross-border e-commerce fulfillment. Expansion. Companies adopt AI-driven trade compliance platforms, blockchain for shipment transparency, and predictive logistics analytics. Digital platforms enhance global freight coordination, reducing delays and improving cost efficiency in international shipping. 6. Sustainability in transportation. Explanation. Sustainable transportation reduces environmental impact through fuel efficiency, alternative energy, and carbon footprint minimization. Companies implement green logistics strategies to comply with regulations and improve operational efficiency while reducing emissions. Real company example. DHL integrates electric delivery vehicles and carbon-neutral shipping programs, reducing emissions and aligning with global sustainability goals. Expansion. Businesses use AI-driven route optimization, alternative fuel vehicles, and carbon tracking tools to enhance sustainability. Investment in green infrastructure, such as charging stations and renewable energy-powered fleets, further reduces environmental impact while improving cost efficiency. 7. Freight consolidation strategies. Explanation. Freight consolidation combines shipments to optimize load capacity, reducing transportation costs and improving efficiency. Methods include less-than-truckload, LTL, full truckload, FTL, cross-docking, and milk runs. Real company example. UPS uses freight consolidation strategies to reduce empty miles, maximize truckloads, and lower per-unit shipping costs across its global distribution network. Expansion. Companies integrate AI-driven load planning and real-time consolidation software. Collaborative shipping models and shared distribution networks further enhance efficiency, minimizing fuel consumption and optimizing logistics expenses. 8. Risk management in transportation. Explanation. Transportation risks include cargo damage, theft, regulatory noncompliance, and delays. Effective risk management ensures supply chain resilience through insurance, security protocols, and contingency planning. Real company example. FedEx employs real-time tracking, cargo insurance, and AI-driven risk mitigation tools to protect shipments from theft and damage while ensuring compliance with transportation regulations. Expansion. Businesses implement IoT-enabled shipment monitoring, predictive risk analytics, and blockchain-based tracking to enhance security. Proactive contingency planning minimizes disruptions, ensuring consistent and reliable transportation services. 9. Regulations governing transportation. Explanation. Transportation regulations govern safety, environmental impact, and trade compliance. Key regulatory bodies include the FMCSA, U.S., ITA, Air Transport, IMO, Maritime, and Customs authorities worldwide. Real company example. Maersk complies with IMO 2020 sulfur regulations by utilizing low-sulfur fuels and adopting emission reduction technologies to meet international shipping standards. Expansion. Companies implement AI-driven compliance monitoring and blockchain-based trade documentation. Automated customs clearance processes improve regulatory adherence while reducing transit delays and non-compliance penalties. 10. Infrastructure and its role in transportation. Explanation. Roads, ports, airports, and intermodal hubs form the foundation of global transportation networks. Infrastructure investments enhance connectivity, reduce congestion, and improve logistics efficiency. Real company example. China's Belt and Road Initiative improves global trade infrastructure, expanding transportation access and reducing logistics costs for international shipping. Expansion. Companies leverage AI-powered traffic management, smart logistics hubs, and real-time infrastructure monitoring. Investments in automated terminals and digital freight corridors further enhance transportation efficiency and supply chain resilience. 11. Technology in transportation. Explanation. Advanced technologies such as GPS tracking, AI-driven route optimization, and telematics enhance transportation efficiency, visibility, and cost control. These tools improve fleet management, reduce delays, and enhance decision-making in logistics operations. Real company example. UPS employs AI-powered route optimization and telematics to reduce fuel consumption and enhance delivery speed, improving cost efficiency and sustainability. Expansion. Companies integrate IoT sensors for real-time shipment tracking, blockchain for secure data sharing, and AI for predictive analytics. Automated fleet management solutions further optimize asset utilization, reducing transportation costs and enhancing service reliability. 12. Reverse logistics and transportation. Explanation. Reverse logistics involves managing returns, recycling, and refurbishments efficiently. Effective transportation planning in reverse logistics reduces costs and enhances sustainability by minimizing waste and optimizing asset recovery. Real company example. Amazon streamlines returns using an optimized reverse logistics network, reducing costs while maximizing the reuse of return products. Expansion. Companies implement AI-powered returns forecasting, automated return processing, and predictive analytics to optimize reverse logistics. Circular supply chains further improve sustainability, reducing waste and enhancing cost recovery. 13. E-commerce and its impact on transportation. Explanation. E-commerce growth demands faster deliveries, last-mile optimization, and flexible logistics networks. Companies must adapt transportation strategies to handle increased demand while maintaining cost efficiency. Real company example. Shopify enables merchants to access optimized last-mile delivery solutions, enhancing delivery speed while reducing logistics costs. Expansion. Businesses invest in AI-driven demand forecasting, autonomous delivery vehicles, and drone technology. Advanced order routing enhances efficiency, while real-time shipment tracking improves customer experience in e-commerce logistics. 14. Capacity planning and carrier selection. Explanation. Effective capacity planning ensures the availability of transportation resources to meet demand fluctuations. Carrier selection strategies involve evaluating cost, reliability, and service quality to optimize logistics operations. Real company example. FedEx optimizes carrier partnerships based on performance metrics, ensuring cost-effective and reliable shipping solutions for global customers. Expansion. Companies use AI-driven capacity forecasting, digital freight marketplaces, and dynamic pricing models. Real-time shipment monitoring further enhances carrier selection, improving flexibility and cost control in transportation networks. 15. Disruptions in transportation. Explanation. Transportation networks face disruptions from weather events, geopolitical issues, and supply chain disturbances. Proactive risk management and contingency planning ensure operational resilience and minimal disruptions. Real company example. Maersk leverages predictive analytics to anticipate supply chain disruptions, optimizing shipping routes and adjusting logistics strategies in real time. Expansion. Businesses integrate AI-driven risk assessments, IoT-based real-time monitoring, and dynamic rerouting strategies. Digital twin technology simulates transportation scenarios, enabling proactive decision-making and improved supply chain resilience. Summary. Technology, reverse logistics, and e-commerce reshape modern transportation networks. Capacity planning ensures reliability, while AI-driven analytics optimize efficiency. Carrier selection strategies enhance cost control, and proactive risk management mitigates disruptions. Businesses leverage automation, real-time tracking, and predictive modeling to build resilient, cost-effective, and sustainable transportation solutions for the evolving global supply chain. Let's take a small practice test for Section A. 1. A company wants to minimize transportation costs while ensuring efficient delivery to multiple customers in the same region. Which strategy should be prioritized? A. Using a dedicated fleet for each customer. B. Implementing freight consolidation. C. Switching to air freight for faster delivery. D. Increasing warehouse locations near customers. Correct answer, B. Explanation. Freight consolidation combines shipments from multiple customers or orders into a single transport load, reducing transportation costs and improving efficiency. 2. Which of the following is a key disadvantage of intermodal transportation? A. Higher lead times due to multiple handling points. B. Inability to transport large shipments. C. Lack of regulatory oversight. D. Higher environmental impact compared to road transport. Correct answer, A. Explanation. Intermodal transportation, while cost-effective and sustainable, often has longer transit times due to multiple handling and modal shifts. 3. A company needs to transport perishable goods internationally. Which mode of transportation should be prioritized? A. Rail transport. B. Ocean freight. C. Air freight. D. Pipeline transport. Correct answer, C. Explanation: air freight is the best option for perishable goods because it provides fast transit times, minimizing spoilage risks. For a retailer needs to balance cost and speed for its transportation operations in an e-commerce-driven supply chain. Which strategy should it use? A. Prioritize ground shipping with regional warehouses. B. Use only express courier services. C. Minimize inventory and rely on just-in-time JIT logistics. D. Increase reliance on ocean freight for cost savings. Correct answer: A. Explanation: regional warehouses combined with ground shipping strike a balance between cost efficiency and delivery speed, optimizing e-commerce logistics. 5. A company is concerned about sustainability and reducing carbon emissions in transportation. Which strategy would be most effective? A. Shifting to electric or alternative fuel vehicles. B. Increasing the use of long-haul trucking. C. Reducing shipment sizes to fit smaller vehicles. D. Expanding express shipping options. Correct answer: A. Explanation: using alternative fuel or electric vehicles reduces emissions, supporting sustainability efforts in logistics. 6. A manufacturer relies on just-in-time JIT supply chain operations. Which transportation risk is most critical to address? A. Carrier selection. B. Infrastructure limitations. C. Delivery delays disrupting production. D. Over-reliance on third-party logistics providers. Correct answer: C. Explanation: JIT operations require precise timing, so any transportation delays can disrupt production and lead to stockouts. 7. A logistics company wants to mitigate risks associated with geopolitical instability affecting its supply chain. Which action is the best strategy? A. Diversifying transportation routes and suppliers. B. Increasing reliance on a single, well-established carrier. C. Reducing transportation insurance coverage. D. Ignoring external factors and focusing on cost reduction. Correct answer: A. Explanation: diversifying routes and suppliers reduce dependency on any single transport route, minimizing risks related to geopolitical instability. 8. A global company is evaluating transportation options to ship bulk raw materials cost-effectively over long distances. Which mode is best suited for this need? A. Air freight. B. Road transport. C. Rail transport. D. Courier services. Correct answer: C. Explanation: rail transport is an efficient and cost-effective mode for moving bulk goods over long distances. 9. A company experiences frequent disruptions due to limited carrier capacity. Which strategy should be adopted to manage this challenge? A. Implementing a diversified carrier strategy. B. Increasing shipment size and frequency. C. Reducing reliance on third-party logistics. D. Shifting all shipments to air transport. Correct answer: A. Explanation: a diversified carrier strategy ensures flexibility, allowing the company to shift shipments when one carrier faces capacity constraints. 10. A retailer is expanding its e-commerce operations and needs a transportation strategy that minimizes last-mile delivery costs. Which option is most effective? A. Using local distribution hubs with optimized route planning. B. Relying only on national carriers for all deliveries. C. Shipping all orders via express courier services. D. Expanding the number of large warehouses instead of local hubs. Correct answer: A. Explanation: local distribution hubs combined with optimized route planning reduce last-mile costs while maintaining fast and efficient deliveries. Section B. Road transportation. Overview. Road transportation is a crucial component of supply chains, offering flexibility, cost-effectiveness, and extensive coverage. It plays a vital role in last-mile delivery, enabling businesses to reach consumers efficiently. Trucks, vans, and drayage services support various logistics needs, from bulk shipments to time-sensitive deliveries. Cost factors such as fuel prices, tolls, and labor impact profitability. Infrastructure quality affects transport efficiency, while technology, like GPS tracking, enhances route planning. Sustainable initiatives, including electric trucks, reduce carbon emissions. Safety regulations ensure compliance, and e-commerce growth fuels demand for rapid deliveries. Fleet management optimizes operations, while intermodal integration enhances multimodal transport solutions. Effective road transportation strategies improve supply chain resilience and operational efficiency. Key topics. 1. Role of road transportation in logistics. Explanation. Road transportation provides flexible and cost-effective logistics solutions, enabling goods to reach destinations efficiently. It supports long-haul trucking, urban deliveries, and last-mile fulfillment, adapting to diverse supply chain needs. Real company example. UPS leverages a vast road transport network, optimizing deliveries through strategic routing, enabling fast and cost-efficient last-mile services. Expansion. Companies implement AI-driven route optimization and dynamic fleet management to enhance delivery efficiency. Telematics improve tracking, while real-time analytics help businesses optimize road transport operations, reducing fuel consumption and delays. 2. Types of road transport. Explanation. Road transport includes full truckload, FTL, less than truckload, LTL, drayage, vans, and last-mile delivery services. Each type serves different logistics needs, balancing speed, cost, and cargo volume. Real company example. Amazon's delivery network integrates LTL for regional shipments and last-mile vans for residential deliveries, ensuring rapid fulfillment and cost-effective transport. Expansion. Businesses adopt hybrid transport models, leveraging LTL for cost savings and FDL for bulk efficiency. AI-powered dispatch systems optimize load distribution, reducing empty miles and improving fleet utilization. 3. Cost factors in road freight. Explanation. Fuel costs, tolls, driver wages, insurance, and vehicle maintenance contribute to road freight expenses. Effective cost management optimizes profitability and enhances supply chain efficiency. Real company example. FedEx employs fuel surcharges and cost index pricing models to mitigate fuel price volatility, stabilizing operational expenses. Expansion. Companies use AI-driven predictive analytics for fuel cost forecasting, automated toll payment systems, and dynamic pricing strategies to optimize freight costs. Sustainable fuel alternatives further enhance cost efficiency. 4. Infrastructure and its impact. Explanation. Road conditions, congestion, and highway quality influence transport efficiency. Well-maintained infrastructure enhances delivery speed and reduces wear on vehicles. Real company example. Walmart strategically places distribution centers near major highways, minimizing travel distances and improving road transport efficiency. Expansion. Governments and businesses invest in smart highways, congestion monitoring systems, and automated traffic routing to optimize road freight efficiency. AI-based predictive maintenance enhances infrastructure planning. 5. Carrier selection and contracting. Explanation. Businesses choose between private fleets, third-party logistics, 3PLs, and for hire carriers based on cost, service level, and operational needs. Real company example. DHL partners with dedicated carriers to ensure high service levels for global e-commerce fulfillment. Expansion. Companies use AI-driven carrier selection tools, performance-based contracts, and digital freight marketplaces to improve decision-making, ensuring cost-effective and reliable transportation partnerships. 6. Fleet management and optimization. Explanation. Effective fleet management improves vehicle utilization, reduces downtime, and enhances route efficiency. Companies use telematics and GPS tracking to monitor fleet performance, reducing costs and improving delivery timelines. Real company example. FedEx employs telematics to track fleet performance, optimizing maintenance schedules and reducing operational disruptions while improving on-time delivery rates. Expansion. Businesses implement AI-powered fleet monitoring, predictive maintenance, and fuel efficiency strategies. Automated route planning enhances productivity, while real-time data analytics improve asset utilization and cost management. 7. Technology in road transport. Explanation. Technology-driven solutions, including AI-powered route planning, GPS tracking, and telematics, optimize delivery efficiency, reduce delays, and improve overall logistics operations. Real company example. UPS utilizes advanced telematics and GPS tracking to optimize delivery routes, reducing fuel consumption and improving fleet efficiency. Expansion. Companies integrate IoT-enabled fleet management, automated dispatching, and AI-based traffic prediction models. Cloud-based transport management systems enhance operational agility, improving cost savings and delivery precision. 8. Sustainability and emission reduction. Explanation. Reducing emissions through fuel-efficient vehicles, alternative energy sources, and regulatory compliance helps companies meet sustainability goals while lowering costs. Real company example. DHL invests in electric delivery vehicles and carbon-neutral shipping solutions to reduce its environmental footprint and meet sustainability targets. Expansion. Businesses adopt AI-driven fuel optimization, hybrid and electric trucks, and carbon tracking tools. Government incentives and sustainability policies encourage cleaner logistics operations, enhancing long-term cost efficiency. 9. Safety regulations and compliance. Explanation. Compliance with safety regulations, including driver working hours, vehicle inspections, and cargo security, ensures operational safety and legal adherence. Real company example. Amazon enforces strict driver compliance policies, integrating electronic logging devices, ELDs, to monitor driving hours and ensure regulatory adherence. Expansion. Companies implement AI-driven compliance tracking, real-time driver monitoring, and automated safety inspections. Predictive analytics enhance risk management, reducing accidents and improving regulatory compliance. 10. E-commerce and last-mile delivery. Explanation. E-commerce growth has increased the demand for fast and flexible last-mile delivery solutions, requiring advanced logistics planning and route optimization. Real company example. Alibaba's Cainiao network leverages AI-driven logistics solutions to optimize last-mile delivery, ensuring rapid and cost-effective fulfillment for e-commerce customers. Expansion. Companies use autonomous delivery vehicles, drone technology, and AI-powered customer demand forecasting to improve last-mile logistics. Real-time tracking and smart lockers further enhance delivery efficiency and customer satisfaction. 11. Challenges in road transport. Explanation. Road transport faces challenges such as driver shortages, fuel price volatility, and regulatory changes. These factors impact delivery reliability, operational costs, and long-term supply chain efficiency. Real company example. FedEx adapts to driver shortages by investing in automated sorting and route optimization, ensuring consistent service levels despite labor constraints. Expansion. Businesses integrate AI-driven workforce planning, predictive fuel cost analytics, and automated compliance tracking. Investments in digital freight platforms improve carrier sourcing and mitigate supply chain disruptions. 12. Cold chain logistics in road transport. Explanation. Cold chain logistics ensures the safe transport of temperature-sensitive goods, including food and pharmaceuticals. Specialized refrigerated trucks maintain product integrity during transit. Real company example. Walmart's grocery division uses temperature-controlled truck fleets to preserve perishable items, reducing spoilage and ensuring food safety. Expansion. Companies implement IoT-enabled temperature monitoring, AI-driven predictive maintenance, and blockchain for cold chain traceability. Real-time alerts improve compliance and reduce product losses in transit. 13. Autonomous and electric vehicles. Explanation. Autonomous and electric vehicles are reshaping road transportation by reducing labor costs, enhancing efficiency, and lowering emissions. These technologies improve sustainability and long-term cost-effectiveness. Real company example. Tesla's semi-trucks offer electric-powered freight solutions, reducing fuel dependency and aligning with sustainability goals. Expansion. Businesses invest in AI-powered fleet automation, advanced battery technology, and autonomous trucking solutions. Regulatory compliance and infrastructure readiness determine the adoption speed of these innovations. 14. Risk management in road transportation. Explanation. Effective risk management mitigates cargo theft, accidents, and operational disruptions. Insurance, security systems, and predictive analytics improve transport safety and reliability. Real company example. DHL integrates real-time cargo tracking and AI-driven risk assessments to prevent theft and reduce supply chain vulnerabilities. Expansion. Companies deploy blockchain for shipment security, IoT-enabled monitoring, and AI-driven predictive risk analytics. Automated insurance claim processing enhances financial protection against transportation risks. 15. Intermodal integration with road transport. Explanation. Intermodal transport combines road, rail, air, and ocean freight for seamless cargo movement. It enhances flexibility, reduces costs, and improves supply chain efficiency. Real company example. Maersk integrates road and rail transport for containerized shipping, reducing congestion and optimizing global freight logistics. Expansion. Businesses leverage digital freight platforms, AI-driven intermodal route planning, and automated load balancing. Investments in smart logistics hubs improve multimodal transitions, reducing handling costs and improving transit efficiency. Summary. Road transportation is evolving with automation, sustainability, and intermodal integration. Companies address challenges like driver shortages and fuel volatility through AI-driven solutions. Cold chain logistics ensures product integrity, while risk management enhances cargo security. Electric and autonomous vehicles redefine efficiency, and intermodal transport streamlines freight movement. Businesses optimize operations through AI, IoT, and advanced logistics planning to ensure resilience and cost-effectiveness. Let's take a small practice test for Section B. 1. A logistics company wants to reduce fuel costs and improve delivery efficiency. Which fleet optimization strategy would be most effective? A. Reducing the number of vehicles in the fleet. B. Using route optimization software to minimize empty miles. C. Increasing the number of long-haul trips. D. Prioritizing same-day delivery for all shipments. Correct answer, B. Explanation. Route optimization software reduces fuel consumption by minimizing empty miles, optimizing delivery schedules, and ensuring efficient fleet utilization. 2. A company needs to transport fragile goods over long distances while minimizing damage risks. Which road transport strategy is most effective? A. Using standard dry vans. B. Implementing shock-absorbing packaging and air ride suspension trucks. C. Consolidating shipments with bulk freight. D. Selecting the fastest delivery route, regardless of road conditions. Correct answer, B. Explanation: air ride suspension trucks reduce vibrations, and protective packaging minimizes damage, ensuring safe transport of fragile goods. 3. A retail business needs to improve last-mile delivery efficiency while minimizing costs. Which solution should it implement? A. Expanding large warehouses in urban areas. B. Using micro-fulfillment centers and crowdsourced delivery services. C. Relying solely on third-party logistics providers, 3PLs. D. Increasing the fleet size without route optimization. Correct answer, B. Explanation: micro-fulfillment centers and crowdsourced delivery reduce last-mile costs while maintaining fast delivery times in urban areas. 4. A carrier wants to comply with new sustainability regulations while maintaining cost-effectiveness. Which action should be prioritized? A. Transitioning to electric or hybrid delivery trucks. B. Increasing vehicle speeds to reduce travel time. C. Reducing the number of rest breaks for drivers. D. Eliminating return logistics operations. Correct answer, A. Explanation: electric and hybrid trucks reduce emissions while ensuring compliance with sustainability regulations and long-term cost savings. 5. A company experiences frequent delays in road transportation due to traffic congestion. What is the best mitigation strategy? A. Increasing fleet size to handle more trips. B. Implementing real-time GPS tracking and dynamic rerouting. C. Choosing cheaper but longer routes. D. Reducing the number of deliveries per day. Correct answer, B. Explanation: real-time GPS tracking and dynamic rerouting allow companies to respond to traffic congestion effectively, reducing delays. 6. Which of the following is a major challenge in cold chain road transportation for perishable goods? A. Fuel consumption of refrigerated trucks. B. Lack of train drivers. C. Complex customs regulations. D. High toll fees on highways. Correct answer, A. Explanation: refrigerated trucks consume more fuel to maintain temperature-sensitive cargo, increasing operational costs. 7. A logistics company is considering using autonomous trucks for long-haul road transport. What is the primary advantage of this approach? A. Reduction in driver-related costs and extended operating hours. B. Increased reliance on human intervention for navigation. C. Higher maintenance costs and limited availability. D. Higher risks due to unpredictable road conditions. Correct answer, A. Explanation: autonomous trucks reduce labor costs and can operate for extended hours without driver fatigue, improving efficiency. 8. A food distributor must maintain product integrity in road transportation while ensuring cost efficiency. Which strategy should be prioritized? A. Using insulated containers with temperature monitoring systems. B. Reducing transportation frequency to save costs. C. Using only non-refrigerated trucks to lower operational expenses. D. Maximizing cargo weight to reduce the number of trips. Correct answer, A. Explanation: insulated containers with temperature monitoring help maintain product integrity while optimizing costs in cold chain logistics. 9. A logistics manager needs to reduce insurance costs for the fleet. Which of the following actions is most effective? A. Implementing telematics and driver behavior monitoring. B. Increasing the number of vehicles in the fleet. C. reducing cargo weight per truck. D. Choosing longer but less congested routes. Correct answer: A. Explanation: telematics and driver behavior monitoring improve safety, reducing accident risks and lowering insurance premiums. 10. A company needs to balance speed, cost, and sustainability in road transport. Which solution offers the best compromise? A. Switching entirely to rail transport. B. Using alternative fuel vehicles and optimizing delivery schedules. C. Prioritizing overnight express trucking for all shipments. D. Increasing the number of trucks on a road. Correct answer: B. Explanation: alternative fuel vehicles reduce emissions and optimized schedules ensure timely deliveries while controlling costs. Let's take a quick break. Now's the perfect time to show some love. Hit that like button, drop a comment, and share this video. Your support keeps us fired up and ready to keep bringing you more awesome content. Section C. Rail Transportation. Overview. Rail transportation plays a critical role in supply chains by offering cost-effective, high-capacity freight movement. It is particularly efficient for bulk commodities and long-distance shipping, reducing congestion on highways and lowering carbon emissions. Rail networks enable seamless intermodal connectivity, enhancing multimodal transport efficiency. Various rail freight types, including intermodal and unit trains, cater to different industry needs. Pricing models provide volume discounts, optimizing cost savings for businesses. Infrastructure investments expand rail connectivity, while technology improves tracking, scheduling, and predictive maintenance. Rail transport faces challenges such as terminal congestion and limited flexibility, but remains vital in global trade and bulk logistics. Sustainable initiatives and automation drive the future of rail freight. Key topics. 1. Role of rail transport in logistics. Explanation: rail transport is essential for moving bulk goods over long distances efficiently. It provides a cost-effective alternative to road and air transport, particularly for heavy commodities such as coal, steel, and agricultural products, reducing congestion and emissions. Real company example: Union Pacific moves millions of tons of bulk freight annually, supporting industries such as agriculture and energy with reliable and cost-efficient rail logistics solutions. Expansion: companies optimize rail transport through AI-powered scheduling, real-time tracking, and integration with multimodal logistics. Automated rail yard operations enhance efficiency, reducing dwell times and improving supply chain reliability. 2. Types of rail freight. Explanation: rail freight consists of intermodal containers, bulk commodities, carload shipments, and unit trains. These categories allow businesses to transport goods efficiently based on cargo type, volume, and destination. Real company example: CSX operates dedicated unit trains for coal and grain shipments, improving efficiency by reducing transit time and handling requirements. Expansion: businesses leverage intermodal rail solutions for seamless transitions between truck, rail, and ocean transport. AI-driven route optimization enhances coordination between different transport modes, improving efficiency and reducing costs. 3. Cost efficiency and pricing models. Explanation: rail freight offers lower per-mile transportation costs, particularly for bulk shipments. Volume discounts and fixed contract pricing models provide businesses with predictable expenses, ensuring cost stability over long distances. Real company example: Canadian National Railway offers volume-based pricing for bulk freight, enabling cost-effective transportation for industries relying on large-scale logistics. Expansion: companies use AI-driven cost modeling to optimize contract negotiations and predict freight expenses. Digital platforms improve pricing transparency, allowing businesses to select the most efficient and cost-effective rail options. 4. Rail versus other transport modes. Explanation. Compared to road and air transport, rail offers cost and environmental benefits, but lacks flexibility. While slower than trucking, it excels in moving heavy goods efficiently over long distances at lower costs. Real company example. Deutsche Bahn provides integrated railroad solutions, leveraging rail for long-haul transport and trucks for last-mile delivery. Expansion. Businesses use AI-powered decision-making tools to balance rail with other modes based on delivery speed, cost efficiency, and cargo type. Enhanced rail truck integration optimizes multimodal logistics strategies. 5. Infrastructure and rail networks. Explanation. Rail transport relies on well-maintained tracks, freight corridors, and terminal access. Infrastructure investments expand network capacity and improve reliability, enabling efficient freight movement. Real company example. Indian Railways invests in dedicated freight corridors to enhance rail logistics efficiency, reducing congestion and increasing cargo throughput. Expansion. Companies leverage predictive maintenance and smart rail systems to enhance infrastructure utilization. AI-driven rail scheduling optimizes asset deployment, improving efficiency and reducing operational bottlenecks. 6. Intermodal rail transport. Explanation. Intermodal rail transport integrates rail, road, and ocean freight for seamless cargo movement. This approach reduces handling costs, improves efficiency, and lowers transportation expenses for businesses shipping across long distances. Real company example. Maersk uses intermodal rail transport to move shipping containers efficiently from ports to inland terminals, reducing road congestion and optimizing supply chain operations. Expansion. Companies leverage AI-driven intermodal logistics platforms to coordinate rail and truck transitions. Real-time tracking and predictive analytics enhance cargo visibility, ensuring efficient multimodal operations and reducing transit times. 7. Rail freight car types. Explanation. Rail freight utilizes various car types, including tank cars for liquids, boxcars for general cargo, flat cars for oversized loads, and refrigerated rail cars for perishables. Selecting the right car type optimizes load capacity and protects cargo integrity. Real company example. BNSF Railway employs specialized rail cars, such as double-stack container cars, to maximize cargo efficiency while ensuring safe and secure transport. Expansion. Businesses implement automated cargo tracking, AI-based load optimization, and climate-controlled rail cars to enhance transport efficiency. Digital twin technology simulates freight movement, improving loading strategies and capacity utilization. 8. Sustainability and fuel efficiency. Explanation. Rail transport is more fuel efficient than road and air freight, reducing carbon emissions and lowering energy consumption. It supports sustainability initiatives while helping companies meet environmental regulations. Real company example. Union Pacific invests in low-emission locomotives and fuel-efficient rail technologies to reduce greenhouse gas emissions and improve sustainability in freight transport. Expansion. Companies adopt AI-powered fuel efficiency models, renewable energy power rail systems, and hybrid locomotives. Carbon tracking tools provide visibility into emissions, helping businesses achieve sustainability goals and regulatory compliance. 9. Technology in rail transport. Explanation. Advanced technologies such as automated tracking, AI-driven route planning, and predictive maintenance enhance rail transport efficiency, reducing costs and improving service reliability. Real company example. Deutsche Bahn uses AI-powered scheduling and real-time freight monitoring to optimize train operations and improve cargo movement efficiency. Expansion. Companies implement IoT-enabled rail cars, blockchain for secure freight transactions, and automated rail yard operations. Predictive analytics help prevent maintenance delays, ensuring smooth rail logistics operations and minimizing service disruptions. 10. Challenges in rail freight. Explanation. Rail freight faces challenges such as limited flexibility, terminal congestion, and regulatory constraints. These factors impact delivery speed and operational efficiency in multimodal logistics. Real company example. Canadian National Railway addresses congestion issues by implementing AI-based train scheduling and optimizing terminal workflows, improving overall rail network efficiency. Expansion. Companies deploy AI-driven congestion prediction tools, automated cargo handling, and real-time freight visibility platforms. Infrastructure investments and regulatory collaboration enhance rail capacity and streamline cargo flow. 11. Safety and compliance in rail transport. Explanation. Rail transport is governed by strict safety and compliance regulations, including hazardous materials handling, track inspections, and operator certifications. Adhering to these standards ensures accident prevention and operational efficiency. Real company example. CSX implements advanced rail inspection technologies and automated safety monitoring to comply with federal regulations, ensuring cargo and personnel safety. Expansion. Companies integrate AI-driven safety analytics, automated compliance tracking, and real-time monitoring systems. Smart sensors enhance track inspections, while digital reporting tools streamline regulatory compliance and risk management. 12. Rail transport in global trade. Explanation. Rail transport facilitates international trade by enabling seamless cross-border freight movement. Trade corridors and customs regulations impact the efficiency and cost of global rail logistics. Real company example. China Railway operates the China-Europe Freight Train Network, reducing transit times for international trade and improving supply chain reliability. Expansion. Businesses leverage blockchain for customs documentation, AI-driven cross-border logistics optimization, and real-time cargo tracking. Trade agreements and digital platforms streamline rail freight movement, enhancing global supply chain connectivity. 13. High-speed rail and freight integration. Explanation. High-speed rail networks are emerging as a viable option for time-sensitive freight, reducing transit times and expanding logistics capabilities for critical goods. Real company example. Japan's Shinkansen high-speed rail integrates freight transport for perishable goods, improving delivery efficiency while maintaining product integrity. Expansion. Companies invest in AI-powered freight scheduling, specialized cargo compartments for high-speed rail, and predictive analytics to optimize load planning. Future advancements in rail electrification enhance efficiency and sustainability. 14. Risk management in rail freight. Explanation. Risk management in rail freight involves securing cargo, preventing damage, and mitigating transit disruptions. Strategies include insurance, security technologies, and contingency planning. Real company example. Canadian Pacific Railway employs real-time cargo security tracking and AI-driven risk assessments to minimize theft and freight damage risks. Expansion. Businesses use IoT-enabled security seals, AI-powered predictive analytics, and automated risk reporting. Digital twin simulations optimize contingency plans, reducing potential delays and improving cargo safety. 15. Future trends in rail logistics. Explanation. The future of rail logistics includes advancements in electrification, digital freight networks, and autonomous rail systems. These innovations improve efficiency, sustainability, and cost-effectiveness. Real company example: Deutsche Bahn invests in autonomous freight trains and AI-driven logistics platforms to enhance rail network efficiency and sustainability. Expansion: companies integrate AI-based automation, green energy-powered locomotives, and advanced cargo monitoring systems. Digital rail freight corridors improve multimodal integration, optimizing global rail supply chain operations. Summary: rail transport is evolving with safety regulations, global trade expansion, and high-speed freight networks. Risk management strategies improve cargo security, while AI-driven automation enhances efficiency. Future trends in electrification, digital rail networks, and autonomous trains shape rail logistics. Businesses optimize operations through advanced tracking, predictive analytics, and sustainable rail transport solutions for long-haul freight. Let's take a small practice test for Section C. 1. A logistics company wants to move bulk commodities such as coal and grain in the most cost-efficient manner. Which type of rail freight should it use? A. Intermodal freight. B. Unit train service. C. Less than truckload, LTL, rail service. D. Double-stacked container trains. Correct answer: B. Explanation: unit trains move a single commodity in large quantities, reducing handling costs and transit times, making them ideal for bulk shipments. 2. A company is considering rail freight for long-distance shipping of containers, but wants to integrate with trucking for first-mile and last-mile delivery. Which transport method should it use? A. Tank cars. B. Unit trains. C. Intermodal rail. D. Mixed cargo freight. Correct answer: C. Explanation: intermodal rail transport allows containers to be moved seamlessly between trains and trucks, optimizing cost and delivery efficiency. 3. Rail transport is often preferred over road transport for long-haul freight because A. It offers more flexible delivery schedules. B. It has lower per-unit transport costs for high-volume shipments. C. It reduces the need for warehousing. D. It eliminates the risk of cargo damage. Correct answer: B. Explanation: rail is cost-effective for long-distance bulk transport due to economies of scale, though it lacks the flexibility of road transport. 4. A logistics manager wants to improve sustainability while reducing fuel costs in freight transportation. Why might rail be a better option than road? A. Rail transport is entirely carbon neutral. B. Rail uses less fuel per ton-mile than trucks. C. Rail networks allow direct door-to-door delivery. D. Rail freight costs remain fixed regardless of fuel prices. Correct answer: B. Explanation: rail transport is more fuel-efficient per ton-mile than road transport, making it a more sustainable and cost-effective option. 5. A freight forwarder is selecting a rail freight car type for transporting liquid chemicals. Which type of rail car is most suitable? A. Boxcar. B. Tank car. C. Flat car. D. Hopper car. Correct answer: B. Explanation: tank cars are specifically designed to transport liquid commodities, including hazardous chemicals, ensuring safe and efficient transport. 6. One of the major challenges in rail logistics is A. Lack of government regulations. B. High fuel costs per mile compared to trucking. C. Limited rail network flexibility and first/last mile challenges. D. Rail transport is the fastest mode for urgent shipments. Correct answer: C. Explanation: rail networks are not as flexible as road transport, requiring intermodal solutions for first-mile and last-mile delivery. 7. How does automation and AI benefit rail freight operations? A. It increases train speed beyond highway limits. B. It enables predictive maintenance, improving reliability and reducing downtime. C. It eliminates the need for all rail personnel. D. It makes rail freight more expensive due to technology costs. Correct answer, B. Explanation. AI and automation enhance rail operations by enabling predictive maintenance, optimizing routing, and reducing delays. 8. A company wants to reduce transit time for high-value goods using rail. What is the best option? A. Conventional freight trains. B. High-speed rail freight. C. Bulk commodity unit trains. D. Mixed freight services. Correct answer, B. Explanation. High-speed rail freight is an emerging solution that reduces transit time for high-value goods, making rail a more competitive option for time-sensitive shipments. 9. What is a key advantage of integrating rail into multimodal logistics? A. It eliminates the need for customs clearance in international trade. B. It reduces reliance on trucking while improving long-haul cost efficiency. C. It ensures 100% delivery speed guarantee. D. It is the most cost-effective option for perishable goods. Correct answer, B. Explanation. Rail integration reduces long-haul trucking reliance and optimizes costs while still requiring intermodal handling for first/last mile delivery. 10. A supply chain manager wants to reduce risks in rail transport. Which strategy is most effective? A. Increasing reliance on a single rail provider for consistency. B. Using predictive analytics and IoT for real-time monitoring. C. Switching all rail shipments to road transport for flexibility. D. Relying solely on government subsidies for rail investment. Correct answer, B. Explanation. Predictive analytics and IoT improve real-time monitoring, reduce delays, and enhance risk management in rail logistics. Section D. Air transport. Overview. Air transport is a crucial component of global supply chains, offering unmatched speed and reliability for time-sensitive and high-value shipments. It is the fastest mode for international freight, ensuring rapid deliveries for e-commerce, pharmaceuticals, and perishables. Despite its high costs, air freight remains essential for emergency logistics and just-in-time supply chain models. Express carriers, dedicated freighters, and charter flights enhance operational flexibility. Air cargo hubs and trade lanes optimize network efficiency, while intermodal connections improve last-mile delivery. Regulatory compliance ensures cargo security and safety. Technological advancements like AI-driven forecasting and RFID tracking enhance efficiency. Sustainability efforts and risk management strategies shape the future of air logistics. Innovations in drone deliveries and electric cargo planes drive industry evolution. Key topics. 1. Role of air transport in logistics. Explanation. Air transport is the fastest mode of freight movement, making it essential for urgent and high-value shipments. It provides global connectivity, ensuring rapid deliveries for industries like healthcare, e-commerce, and high-tech manufacturing. Real company example. FedEx Express leverages air transport to guarantee overnight deliveries worldwide, ensuring supply chain continuity for businesses requiring just-in-time inventory management. Expansion. Companies use AI-powered route optimization and dynamic scheduling to enhance air cargo efficiency. Advanced cargo tracking systems improve visibility, while automated handling solutions reduce turnaround times, increasing operational effectiveness. 2. Types of air freight. Explanation. Air freight includes express services, commercial cargo, dedicated freighters, and charter flights. Each type serves different shipping needs, balancing speed, cost, and cargo requirements. Real company example: DHL Express operates dedicated freighters for time-critical shipments, ensuring reliable delivery within strict time frames. Expansion: businesses optimize freight selection using AI-driven demand forecasting and automated load planning. Integrated air freight networks improve scheduling efficiency, ensuring seamless cargo transitions between different shipment types. 3. Cost structure and pricing. Explanation: air freight is the most expensive transport mode, with pricing based on weight, volume, and fuel surcharges. Costs fluctuate due to demand, fuel prices, and airport fees. Real company example: Emirates Sky Cargo implements dynamic pricing strategies, adjusting rates based on cargo demand, fuel costs, and seasonal fluctuations. Expansion: companies use AI-powered freight cost modeling and digital booking platforms to optimize pricing strategies. Predictive analytics help businesses manage expenses, ensuring cost-effective air transport solutions without sacrificing efficiency. 4. Air versus other transport modes. Explanation: air transport offers unmatched speed but at a higher cost than road, rail, or ocean freight. It is ideal for perishable goods, emergency shipments, and high-value cargo, requiring quick delivery. Real company example: Amazon Air balances air and ground transportation to achieve next-day and same-day delivery, optimizing efficiency while managing costs. Expansion: businesses integrate intermodal strategies, combining air transport with last-mile road logistics. AI-driven shipment routing optimizes modal selection, balancing cost and transit time for supply chain efficiency. 5. Air freight capacity and load planning. Explanation: effective load planning optimizes cargo capacity using unit load devices, ULDs, and volume-based configurations. Maximizing space utilization reduces costs and improves operational efficiency. Real company example: Lufthansa Cargo uses AI-based load optimization to increase cargo space utilization, reducing fuel consumption per shipment. Expansion: companies implement automated cargo weight distribution and real-time load monitoring to optimize payload efficiency. AI-powered forecasting improves capacity planning, ensuring cost-effective and sustainable air freight operations. 6. Major air cargo hubs and routes. Explanation: major air cargo hubs and trade routes connect global supply chains, ensuring efficient freight movement. Key airports facilitate rapid cargo handling and streamlined customs clearance, improving transit times and logistics efficiency. Real company example: Hong Kong International Airport is the world's busiest air cargo hub, handling millions of tons annually to support global trade and e-commerce logistics. Expansion: businesses utilize AI-driven route optimization and digital freight platforms to improve efficiency. Automated cargo handling and real-time tracking at major hubs enhance speed, minimizing delays, and optimizing air freight logistics. 7. Intermodal integration with air freight. Explanation: intermodal integration combines air freight with road, rail, and ocean transport for seamless logistics operations. It enhances efficiency, reduces transit times, and ensures cost-effective last-mile delivery. Real company example: UPS integrates air and ground transportation networks, ensuring quick transitions between modes to meet global delivery deadlines. Expansion: businesses implement AI-powered intermodal route planning, automated transfer hubs, and real-time cargo tracking. Digital logistics platforms improve modal coordination, enhancing flexibility and reducing costs in air cargo distribution. 8. Regulatory compliance in air cargo. Explanation: air cargo is subject to strict regulations from ITA, TSA, and ICAO, covering security, customs clearance, and hazardous materials handling. Compliance ensures safety and smooth international freight movement. Real company example: Emirates Sky Cargo adheres to IATA's live animals regulations, ensuring safe transportation for perishable and live cargo. Expansion: companies use AI-driven compliance tracking, blockchain for secure documentation, and automated cargo screening to streamline regulatory adherence. Digital customs processing enhances efficiency, reducing delays in international air freight. 9. E-commerce and air freight. Explanation: the rise of e-commerce has increased demand for express air shipping, ensuring fast, reliable deliveries. Retailers and logistics providers leverage air transport to meet customer expectations for speed and service. Real company example: Amazon Air operates a dedicated air cargo network, ensuring rapid fulfillment and next-day delivery for prime customers. Expansion: businesses deploy AI-driven demand forecasting, autonomous sorting centers, and drone technology to enhance air cargo efficiency. Automated fulfillment centers improve processing speed, reducing lead times in e-commerce logistics. 10. Technology in air transport. Explanation: advanced technologies such as AI, RFID tracking, and predictive analytics improve air cargo efficiency, security, and cost-effectiveness. These tools optimize operations and enhance supply chain visibility. Real company example: FedEx utilizes AI-powered cargo tracking and predictive analytics to improve delivery accuracy and reduce transit disruptions. Expansion: companies implement IoT-enabled air freight monitoring, real-time flight tracking, and blockchain for secure air cargo transactions. AI-driven automation enhances load balancing, optimizing fuel efficiency and air cargo space utilization. 11. Cold chain logistics in air transport. Explanation: air transport is critical for cold chain logistics, ensuring temperature-sensitive cargo, such as pharmaceuticals, perishable food, and medical supplies, maintain required conditions throughout transit. Real company example: Qatar Airways Cargo operates temperature-controlled air freight solutions for pharmaceutical shipments, using advanced cooling technologies to preserve product integrity. Expansion: businesses integrate IoT-enabled temperature monitoring, AI-driven predictive analytics, and blockchain for supply chain transparency. Automated climate-controlled storage at airports enhances cold chain efficiency, reducing spoilage and improving regulatory compliance. 12. Sustainability and carbon emissions. Explanation: air transport has a high carbon footprint, but sustainability initiatives aim to reduce emissions through fuel-efficient aircraft, carbon offset programs, and alternative energy sources. Real company example: Lufthansa Cargo invests in sustainable aviation fuel, SAF, to lower carbon emissions, supporting the industry's long-term environmental goals. Expansion: companies use AI-driven flight path optimization, electric ground handling equipment, and carbon tracking software to reduce environmental impact. Advancements in fuel efficiency and hybrid propulsion systems further enhance sustainability in air freight operations. 13. Risk management in air freight. Explanation: risk management in air freight focuses on cargo security, theft prevention, and damage mitigation through regulatory compliance, tracking technologies, and insurance strategies. Real company example: DHL Express employs AI-powered cargo monitoring systems and predictive analytics to reduce in-transit risks and enhance cargo protection. Expansion: Businesses implement real-time IoT tracking, AI-driven risk assessments, and blockchain-secured documentation. Advanced cargo handling automation reduces human error, enhancing security and shipment reliability. 14. Future trends in air logistics. Explanation. Emerging trends in air logistics include drone deliveries, electric cargo planes, and AI-powered automation, improving efficiency, reducing costs, and expanding delivery capabilities. Real company example. Amazon Prime Air develops drone delivery solutions to enhance last-mile logistics, enabling faster and more cost-effective deliveries. Expansion. Companies invest in AI-driven route optimization, autonomous cargo aircraft, and sustainable aviation technologies. Blockchain-integrated digital freight platforms enhance transparency, efficiency, and predictive analytics for future air freight advancements. 15. Emergency and disaster relief logistics. Explanation. Air transport plays a crucial role in disaster relief, delivering medical supplies, food, and emergency aid to affected areas quickly and efficiently. Real company example. FedEx supports humanitarian relief efforts by transporting emergency supplies via air cargo to disaster-affected regions, ensuring rapid response. Expansion. Governments and NGOs collaborate with logistics providers to deploy AI-driven relief planning, drone-assisted deliveries, and real-time cargo tracking. Automated inventory systems enhance emergency logistics efficiency, improving response time and resource allocation. Summary. Cold chain logistics, sustainability, and risk management shape air freight operations. Advanced tracking, AI-driven automation, and fuel-efficient technologies enhance efficiency and reduce emissions. Future trends in drones, electric cargo planes, and predictive analytics optimize air logistics. Emergency relief efforts benefit from rapid air transport solutions, reinforcing air freight's critical role in global supply chains. Let's take a small practice test for Section D. 1. A logistics manager needs to transport perishable goods internationally with strict temperature control. Which air freight solution is best suited for this shipment? A. Standard commercial air cargo. B. Express air freight. C. Charter flight with cold chain logistics. D. Economy air freight service. Correct answer. C. Explanation. Charter flights with cold chain logistics ensure precise temperature control, essential for pharmaceuticals, perishable foods, and medical supplies. 2. A company is choosing between air and ocean freight for urgent, high-value electronic components. What is the primary reason for selecting air transport? A. Air transport has lower customs clearance times. B. Air transport has lower overall costs for high-volume shipments. C. Air transport offers the fastest transit time. D. Air transport eliminates all risks of damage. Correct answer. C. Explanation. Air transport is the fastest mode, making it the best choice for urgent, high-value shipments despite higher costs. 3. Which of the following best describes a unit load device, ULD, in air cargo logistics? A. A standard container used in ocean freight. B. A device that enhances fuel efficiency in aircraft. C. A pallet or container used to consolidate air cargo shipments. D. A regulatory requirement for air cargo tracking. Correct answer. C. Explanation. ULDs optimize space utilization and streamline cargo handling in air freight operations. 4. How does e-commerce impact air freight logistics? A. Increases demand for express and overnight deliveries. B. Reduces the need for air cargo services. C. Eliminates the need for warehouse storage. D. Decreases the frequency of international shipments. Correct answer: A. Explanation: the rise of e-commerce has significantly increased demand for express air freight and faster global shipping solutions. 5. A company wants to reduce carbon emissions while using air freight. Which strategy is most effective? A. Utilizing older aircraft to maximize cargo loads. B. Implementing lightweight ULDs and fuel-efficient aircraft. C. Reducing the number of flights while increasing shipment size. D. Shifting all shipments to sea freight. Correct answer: B. Explanation: using fuel-efficient aircraft and lightweight materials reduces fuel consumption and minimizes the environmental impact of air transport. 6. Which regulation primarily governs international air cargo transportation standards? A. ICAO, International Civil Aviation Organization. B. IMO, International Maritime Organization. C. UIC, International Union of Railways. D. WCO, World Customs Organization. Correct answer: A. Explanation: the ICAO sets global standards for aviation safety, including air cargo regulations and security. 7. A logistics company must transport hazardous materials via air freight. Which compliance standard must be strictly followed? A. TSA cargo compliance. B. IATA dangerous goods regulations, DGR. C. ISO 9001 certification. D. ATA freight guidelines. Correct answer: B. Explanation: the IATA DGR outlines specific safety and handling regulations for transporting hazardous materials by air. 8. A freight forwarder is optimizing air cargo load planning. What is the most critical factor in determining cargo capacity for an aircraft? A. Gross weight of the cargo. B. Volume and weight balance, chargeable weight. C. Number of ULDs used. D. Destination airport regulations. Correct answer: B. Explanation: air cargo is charged based on volumetric weight, making weight balance and volume optimization crucial for efficient load planning. Which of the following is a key risk in air freight logistics? A. Longer transit times than ocean freight. B. Higher potential for cargo theft compared to road transport. C. Cost volatility due to fuel price fluctuations. D. Greater susceptibility to supply chain disruptions than rail freight. Correct answer: C. Explanation: air freight costs are highly sensitive to fuel price changes, impacting transportation expenses and pricing models. Which future trend is most likely to shape the air cargo industry? A. Increased use of AI and predictive analytics for route optimization. B. Complete replacement of air cargo with autonomous trucks. C. Elimination of customs regulations for air freight. D. Reduction of global trade due to automation. Correct answer: A. Explanation: AI and predictive analytics improve efficiency, reduce costs, and optimize air freight operations by improving demand forecasting and route planning. Quick reminder: if you're finding this helpful, don't forget to like, subscribe, and share with anyone who may benefit. Your support really makes a difference. Let's get back to it. Section E. Ocean and Inland Waterway Transportation. Overview. Ocean and inland waterway transportation are essential for global trade, handling over 80% of total cargo movement. These transport modes provide cost-effective solutions for bulk and containerized freight, reducing reliance on air and road transport. Shipping lines utilize major global routes and ports for efficient cargo handling. Containerization improves intermodal connectivity, optimizing supply chains. Vessel types range from ultra-large container ships to specialized bulk carriers. Regulations ensure maritime safety and environmental sustainability. Cold chain logistics facilitate perishable goods transport. Risk management strategies address security threats, piracy, and insurance challenges. Advances in port automation and green shipping initiatives improve efficiency. Future trends include autonomous vessels, digital freight platforms, and expanded e-commerce integration. Key topics. 1. Role of ocean freight in global trade. Explanation. Ocean freight is the backbone of global trade, facilitating large-scale cargo transport at cost-effective rates. It handles diverse commodities, including raw materials, manufactured goods, and consumer products, supporting economic growth worldwide. Real company example. Maersk operates one of the largest container shipping fleets, enabling cost-efficient global trade by transporting millions of TEUs annually across major shipping lanes. Expansion. Companies integrate AI-powered freight forecasting, digital booking platforms, and smart container tracking to optimize efficiency. Blockchain enhances transparency, reducing paperwork and improving end-to-end shipment visibility. 2. Types of ocean cargo. Explanation. Ocean cargo includes containerized freight, bulk commodities, break bulk, roll-on/roll-off, RORO, liquid cargo, and project cargo. Each type requires specialized handling and transportation methods. Real company example. CMA-CGM provides specialized shipping solutions for oversized project cargo, ensuring secure transport for energy sector equipment and heavy machinery. Expansion. Businesses use AI-driven cargo planning, specialized vessel configurations, and advanced loading techniques to optimize transport efficiency. Smart sensors improve cargo condition monitoring, reducing losses during transit. 3. Shipping costs and pricing models. Explanation. Ocean freight pricing includes base freight rates, fuel surcharges (BEF), currency adjustment factors (CAF), and additional charges like detention and demurrage. Pricing is influenced by supply-demand dynamics, fuel prices, and geopolitical factors. Real company example. MSC applies flexible pricing models, leveraging long-term contracts and spot market pricing to balance costs and service efficiency. Expansion. Companies implement AI-driven freight cost forecasting, digital contract management, and fuel-efficient routing strategies. Automated cost optimization tools enhance budget management and profitability. 4. Major global shipping routes and ports. Explanation. Key shipping routes include the Suez Canal, Panama Canal, and Trans-Pacific and Transatlantic corridors. Major ports act as critical hubs for container and bulk freight movement. Real company example. DP World operates high-efficiency terminals in key global ports, streamlining cargo handling and reducing vessel turnaround times. Expansion. Businesses leverage AI-powered berth scheduling, automated cranes, and blockchain for real-time port logistics coordination. Smart ports enhance operational flow, reducing delays and improving global trade efficiency. 5. Vessel types and capabilities. Explanation. Ocean vessels include ultra-large container ships, tankers, bulk carriers, and specialized ships for niche cargo. These vessels optimize capacity utilization and fuel efficiency, improving overall maritime logistics. Real company example. Evergreen operates some of the world's largest container ships, enhancing cargo throughput while reducing emissions per TEU transported. Expansion. Companies invest in AI-based fuel consumption monitoring, LNG-powered vessels, and automated cargo management systems. Predictive maintenance reduces downtime, ensuring fleet reliability and operational cost savings. 6. Intermodal integration with ocean freight. Explanation: ocean freight relies on intermodal connectivity, enabling seamless transitions between sea, road, and rail transport. Efficient port infrastructure and logistics networks improve cargo flow and reduce transit times. Real company example: Costco integrates port-to-rail and port-to-road logistics, ensuring smooth cargo transitions across multimodal networks for faster and cost-effective distribution. Expansion: businesses deploy AI-powered logistics platforms, automated container handling, and digital freight coordination to streamline intermodal transfers. Smart port infrastructure enhances real-time cargo tracking and load balancing, improving operational efficiency. 7. Regulations governing ocean transport. Explanation: maritime regulations govern environmental standards, vessel safety, and trade compliance. Organizations like the IMO, SALAS, and MARPOL set global guidelines for cargo security, emissions, and vessel operations. Real company example: Hapag-Lloyd complies with IMO 2020 regulations by implementing low-sulfur fuel alternatives, reducing environmental impact while maintaining operational efficiency. Expansion: companies integrate AI-driven compliance monitoring, blockchain for customs documentation, and automated emissions tracking to ensure regulatory adherence. Digital freight platforms enhance trade transparency, improving compliance efficiency. 8. Sustainability in maritime logistics. Explanation: sustainability initiatives in ocean transport focus on reducing emissions, optimizing fuel efficiency, and adopting green technologies like LNG-powered vessels and alternative energy sources. Real company example: CMA CGM deploys LNG-powered container ships, cutting carbon emissions and improving fuel efficiency to align with global sustainability goals. Expansion: businesses invest in AI-powered route optimization, hybrid propulsion systems, and carbon tracking software. Smart fuel management solutions and energy-efficient vessel designs enhance sustainability in maritime logistics. 9. Inland waterway transport. Explanation: inland waterway transport uses rivers, canals, and barges for efficient bulk freight movement. It provides cost-effective alternatives to road and rail transport, reducing congestion and emissions. Real company example: European inland waterways facilitate freight movement via the Rhine River, optimizing regional distribution and minimizing transport costs. Expansion: businesses integrate AI-driven cargo routing, automated barge scheduling, and real-time water level monitoring. Digital tracking systems enhance inland waterway logistics, improving efficiency and cargo security. 10. Containerization and port automation. Explanation: containerization standardizes cargo handling, improving efficiency and reducing transit times. Automated port operations enhance loading/unloading speed, minimizing vessel turnaround time. Real company example: DP World employs AI-driven port automation and automated container cranes, expediting cargo handling and improving port efficiency. Expansion: companies implement blockchain for container tracking, AI-powered port logistics, and smart yard management systems. Automated customs clearance and real-time cargo visibility improve supply, chain efficiency, and cost effectiveness. 11. Cold chain logistics in ocean freight. Explanation: cold chain logistics in ocean freight ensures temperature-sensitive cargo, such as pharmaceuticals and perishable food, remains in optimal conditions throughout transit. Real company example: Maersk's Captain Peter reefer containers use remote temperature monitoring, ensuring pharmaceutical shipments maintain required storage conditions during long-haul ocean transport. Expansion. Businesses integrate IoT-enabled reefers, AI-driven predictive temperature control, and blockchain-based tracking for real-time cargo visibility. Automated cold chain monitoring improves efficiency, reducing spoilage and enhancing compliance with regulatory standards. 12. Risk management in ocean transport. Explanation. Effective risk management in ocean transport mitigates threats such as cargo theft, piracy, weather disruptions, and supply chain delays through security protocols and contingency planning. Real company example. MSC employs advanced vessel tracking and piracy risk assessment models to ensure cargo security in high-risk shipping lanes. Expansion. Companies deploy AI-driven risk analytics, satellite-based cargo tracking, and automated security response systems. Blockchain-secured documentation minimizes fraud, ensuring safer and more reliable global freight operations. 13. Challenges in ocean freight. Explanation. Ocean freight faces challenges such as port congestion, geopolitical disruptions, fuel price fluctuations, and extreme weather events, impacting supply chain reliability. Real company example. Hapag-Lloyd implements AI-powered congestion monitoring and alternative routing strategies to mitigate delays caused by port bottlenecks. Expansion. Businesses use predictive analytics, smart berth scheduling, and automated customs clearance to streamline operations. Digital twin simulations help model supply chain risks, improving contingency planning. 14. Future trends in ocean shipping. Explanation. The future of ocean freight includes autonomous vessels, digital freight platforms, green shipping corridors, and AI-driven predictive logistics. Real company example. Nippon Yusen Kaisha, NYK, is developing autonomous cargo ships to enhance maritime safety, reduce fuel consumption, and improve operational efficiency. Expansion. Companies invest in AI-powered fleet automation, alternative energy solutions like hydrogen fuel, and blockchain-based digital freight networks. Smart shipping corridors enhance global trade efficiency, reducing transit times and emissions. 15. E-commerce and ocean freight. Explanation. The rise of e-commerce is reshaping ocean freight logistics, increasing demand for direct manufacturer-to-consumer bulk shipments and faster port processing times. Real company example. Alibaba's Cainiao network optimizes ocean freight logistics for cross-border e-commerce, integrating automated fulfillment centers and AI-driven shipment forecasting. Expansion. Businesses implement AI-driven demand planning, smart port logistics, and real-time inventory tracking. Automated customs processing accelerates cross-border shipping, improving efficiency and meeting growing e-commerce demands. Summary. Cold chain logistics, risk management, and digital transformation are shaping ocean transport efficiency. AI-driven predictive analytics, autonomous vessels, and sustainable fuel solutions enhance operations. E-commerce growth accelerates direct shipments, while blockchain and automated port logistics improve security and efficiency. Future advancements in smart shipping corridors and alternative energy drive the evolution of ocean freight logistics. Let's take a small practice test for Section E. 1. A manufacturer needs to transport heavy industrial equipment internationally at the lowest cost. Which ocean cargo type is most suitable? A. Containerized cargo. B. Break bulk cargo. C. RORO cargo. D. Liquid bulk cargo. Correct answer, B. Explanation. Break bulk cargo is best for oversized, heavy industrial equipment that cannot fit into standard containers and requires specialized handling. 2. A logistics manager must select a vessel type to transport massive quantities of coal and iron or across oceans. Which vessel type is the most appropriate? A. Tanker. B. Ultra-large container vessel, ULCV. C. Bulk carrier. D. RORO vessel. Correct answer, C. Explanation. Bulk carriers are designed for transporting large volumes of loose dry cargo, such as coal, ore, and grains efficiently. 3. Which cost component has the greatest impact on ocean freight rates? A. Port handling charges. B. Fuel surcharges. C. Inland trucking fees. D. Customs duties. Correct answer, B. Explanation. Fuel surcharges significantly affect ocean freight rates as fuel costs fluctuate and directly impact operating expenses for shipping lines. 4. A company needs to transport perishable goods via ocean freight. What is the best solution? A. Standard containers. B. Dry bulk carriers. C. Reefer containers. D. Tanker vessels. Correct answer, C. Explanation. Reefer containers, refrigerated containers, are designed for transporting temperature-sensitive goods such as food and pharmaceuticals. 5. Which regulation governs safety standards for international maritime transport? A. MARPOL. B. SALAS. C. IMODGR. D. ITA. Correct answer, B. Explanation. SALAS, Safety of Life at Sea, sets safety standards for international maritime transport, ensuring vessel and crew safety. 6. What is the primary environmental concern in ocean shipping? A. Overloading vessels. B. Fuel efficiency and emissions. C. Shorter transit times. D. Higher containerization costs. Correct answer, B. Explanation. Fuel efficiency and emissions are major concerns in ocean shipping, as the industry seeks to reduce carbon footprints and comply with sustainability regulations. 7. A freight forwarder is considering inland waterway transport for bulk goods. What is a major advantage of this mode? A. Fast transit times. B. Lower cost per ton mile. C. Greater flexibility for small shipments. D. Minimal dependence on weather conditions. Correct answer, B. Explanation. Inland waterway transport is cost-effective for bulk shipments due to its low cost per ton mile compared to road and rail transport. 8. How does automation in container ports improve supply chain efficiency? A. Reduces manual labor but increases fuel consumption. B. Increases terminal throughput and reduces congestion. C. Lowers customs clearance requirements. D. Eliminates the need for intermodal transportation. Correct answer, B. Explanation. Port automation enhances efficiency by speeding up cargo handling, reducing delays, and improving container terminal operations. 9. A company is planning intermodal transportation for long-distance international shipping. Why is ocean freight often preferred for cost efficiency? A. Lower fuel costs compared to rail. B. High capacity and lower cost per unit for bulk shipments. C. Less regulatory compliance compared to air transport. D. Faster transit times than road transport. Correct answer, B. Explanation. Ocean freight is highly cost-efficient due to its ability to move large volumes at a lower per-unit cost, especially for bulk shipments. 10. What is a major risk factor in ocean freight transportation? A. Increased use of autonomous vessels. B. Fluctuations in freight demand. C. Strict environmental laws. D. Geopolitical tensions and piracy. Correct answer, D. Explanation. Geopolitical tensions and piracy pose security risks for ocean freight, affecting trade routes and requiring risk management strategies. Section F. Intermodal and other transportation modes. Overview. Intermodal and alternative transportation modes enhance supply chain efficiency by integrating multiple transport methods to optimize costs, reduce environmental impact, and improve transit times. Standardized containers enable seamless modal transitions, while intermodal terminals and hubs support efficient cargo transfers. Railroad and ocean rail systems improve long-haul logistics, while truck-air intermodal solutions expedite global shipments. Sustainability initiatives prioritize low-emission transport modes, improving eco-friendly logistics. Challenges in intermodal coordination require advanced technological solutions like AI-driven freight management and blockchain-enabled tracking. Pipelines, drones, and emerging technologies like Hyperloop offer alternative transport options for specialized freight. Risk management ensures cargo security, damage prevention, and supply chain resilience. Future trends focus on automation, digital freight networks, and sustainable multimodal solutions. Key topics. 1. Definition and benefits of intermodal transportation. Explanation. Intermodal transportation combines multiple transport modes, such as rail, road, air, and sea, to optimize efficiency, reduce costs, and improve supply chain flexibility. Real company example. UPS integrates intermodal logistics by leveraging rail and truck transport to optimize cost-effective freight movement while reducing carbon emissions. Expansion. Companies use AI-driven route optimization, real-time tracking, and automated scheduling to enhance intermodal efficiency. Digital freight networks improve carrier coordination, ensuring seamless cargo transfers across transport modes. 2. Intermodal containers and standardization. Explanation. Standardized intermodal containers streamline cargo handling across transport modes, enabling seamless transitions and reducing handling costs. ISO standards ensure compatibility with global logistics networks. Real company example. Maersk utilizes standardized containers and smart tracking technology to enhance cargo visibility and facilitate efficient intermodal transitions. Expansion. Businesses implement IoT-enabled container monitoring, AI-driven load optimization, and blockchain-based tracking to improve container utilization and enhance supply chain transparency. 3. Railroad intermodal freight. Explanation. Railroad intermodal freight leverages rail for long-haul transportation and trucks for last-mile delivery, reducing fuel consumption and improving cost efficiency. Real company example. BNSF Railway operates double-stack rail transport, optimizing freight movement efficiency while reducing trucking costs. Expansion. Companies integrate automated rail yard operations, AI-powered freight scheduling, and digital load matching platforms to streamline railroad intermodal logistics. 4. Ocean rail intermodal systems. Explanation. Ocean rail intermodal systems connect ports with inland rail hubs, facilitating seamless international cargo movement while reducing reliance on long-haul trucking. Real company example. DP World enhances port connectivity through rail integration, expediting containerized shipments from maritime hubs to inland destinations. Expansion. Businesses deploy predictive analytics, smart transloading facilities, and automated terminal coordination to improve ocean rail efficiency and reduce dwell times. 5. Truck-air intermodal logistics. Explanation. Truck-air intermodal logistics enable fast, reliable global freight movement by combining trucking for first-mile and last-mile transport with air cargo for expedited shipping. Real company example. FedEx integrates truck-air logistics to ensure overnight deliveries and global express freight solutions. Expansion. Companies implement AI-driven load balancing, autonomous ground transport, and real-time tracking to optimize truck-air logistics for just-in-time deliveries. 6. Cost and efficiency of intermodal transport. Explanation. Intermodal transport balances speed, flexibility, and cost savings by optimizing cargo transitions across multiple transport modes. This method reduces fuel expenses and improves shipment planning. Real company example: CSX Transportation offers intermodal services that reduce long-haul trucking costs, improving overall supply chain cost efficiency. Expansion: businesses deploy AI-driven cost modeling, predictive analytics for load balancing, and automated scheduling to optimize cost-efficient intermodal logistics. 7. Intermodal terminals and hubs. Explanation: intermodal terminals and hubs act as key points for freight transfer between rail, truck, air, and ocean transport, ensuring seamless logistics coordination. Real company example: Union Pacific operates intermodal terminals that integrate rail and trucking networks, optimizing cargo movement across North America. Expansion: companies invest in AI-powered hub management, smart container handling systems, and real-time freight tracking to enhance intermodal terminal efficiency. 8. Sustainability and environmental impact. Explanation: intermodal transport reduces carbon emissions by shifting freight from high-emission modes like trucks to more sustainable rail and waterway solutions. Real company example: DB Schenker prioritizes intermodal solutions, integrating rail transport to cut carbon emissions and improve environmental responsibility. Expansion: businesses utilize alternative fuels, AI-based emission tracking, and multimodal route optimization to enhance sustainability in intermodal logistics. 9. Challenges in intermodal transport. Explanation: intermodal logistics face challenges such as regulatory differences, infrastructure limitations, and complex coordination among multiple carriers. Real company example: Hapag-Lloyd navigates international regulations by implementing standardized documentation and digital compliance tracking to streamline intermodal operations. Expansion: companies integrate AI-driven logistics platforms, blockchain-based freight documentation, and automated load matching systems to address intermodal transport challenges. 10. Technological advancements in intermodal logistics. Explanation: technology enhances intermodal logistics through AI-driven route optimization, blockchain for secure transactions, and digital freight matching for load efficiency. Real company example: Schneider National uses AI-powered freight optimization tools to improve intermodal network efficiency and reduce transit costs. Expansion: businesses adopt IoT-enabled cargo tracking, real-time supply chain visibility, and machine learning-based route planning to advance intermodal logistics operations. 11. Alternative transport modes. Pipelines. Explanation: pipelines transport liquid and gas commodities efficiently over long distances, reducing reliance on trucks and rail for bulk fuel movement while minimizing environmental impact. Real company example: TransCanada operates an extensive pipeline network, ensuring cost-effective and reliable transportation of crude oil and natural gas across North America. Expansion: businesses deploy IoT-based pipeline monitoring, AI-driven leak detection, and automated flow control systems to improve efficiency and reduce environmental risks in fuel transportation. 12. Alternative transport modes. Drones. Explanation: drones provide fast, flexible, last-mile delivery solutions for lightweight cargo, reducing reliance on traditional ground transport and improving service in remote locations. Real company example: Amazon Prime Air utilizes drone technology for rapid e-commerce deliveries, improving speed and efficiency in short-range logistics. Expansion: companies invest in AI-powered drone navigation, automated warehousing integration, and regulatory compliance systems to scale drone-based logistics for urban and rural freight distribution. 13. Alternative transport modes. Hyperloop and future technologies. Explanation. Hyperloop and emerging technologies offer high-speed freight solutions, reducing transit times and optimizing long-haul logistics with energy-efficient alternatives to conventional transport. Real company example. Virgin Hyperloop develops freight-focused transport solutions, aiming to revolutionize cargo movement through ultra-fast, low-energy vacuum tube systems. Expansion. Businesses explore AI-driven cargo scheduling, magnetic levitation logistics networks, and smart infrastructure development to support future Hyperloop freight applications in global supply chains. 14. Risk management in intermodal logistics. Explanation. Effective risk management ensures cargo security, mitigates damage risks, and minimizes disruptions in intermodal logistics through contingency planning and security protocols. Real company example. DHL Global Forwarding integrates AI-driven risk assessment and predictive analytics to enhance cargo protection and reduce operational disruptions. Expansion. Companies deploy blockchain for secure documentation, IoT-enabled real-time cargo tracking, and automated risk alert systems to improve resilience and reduce intermodal supply chain vulnerabilities. 15. Future trends in multimodal freight solutions. Explanation. The future of multimodal freight includes increased automation, AI-driven logistics optimization, and the integration of autonomous transport modes to improve cost efficiency and sustainability. Real company example. FedEx is developing AI-powered autonomous freight systems, integrating robotic sorting, predictive routing, and self-driving transport solutions for efficient multimodal logistics. Expansion. Companies invest in digital freight marketplaces, AI-based network optimization, and energy-efficient multimodal hubs to streamline future logistics operations and reduce costs while enhancing delivery speed. Summary. Intermodal transport continues evolving with alternative modes like pipelines, drones, and Hyperloop, improving speed, efficiency, and sustainability. Risk management strategies enhance security and resilience, while AI and automation drive next-generation multimodal logistics. Digitalization and autonomous transport modes shape the future, ensuring cost-effective, low-emission freight solutions across global supply chains. Let's take a small practice test for Section F. 1. A logistics manager needs to transport high-value electronics across long distances while minimizing costs and ensuring security. Which intermodal strategy is the most suitable? A. Rail ocean road. B. Air truck. C. Rail truck. D. Pipeline road. Correct answer. C. Explanation. Rail truck intermodal transport is cost-effective, reduces handling risks, and ensures security for high-value goods over long distances. 2. Which factor is the biggest advantage of intermodal transportation compared to single-mode transport? A. Faster transit times. B. Reduced handling and improved security. C. Higher flexibility in route selection. D. Lower customs requirements. Correct answer. B. Explanation. Intermodal transport reduces handling by using standardized containers, lowering damage risk, and improving cargo security. 3. Which technological advancement is most beneficial in enhancing intermodal coordination and real-time tracking? A. Blockchain. B. GPS-based fleet management. C. AI-based demand forecasting. D. Warehouse automation. Correct answer. A. Explanation. Blockchain enhances transparency and security in intermodal logistics by providing an immutable, real-time record of shipments across multiple modes. For what is a major limitation of intermodal transportation? A. High fuel costs. B. Inconsistent transit times due to mode coordination challenges. C. Limited availability of transport hubs. D. High carbon emissions compared to air freight. Correct answer, B. Explanation. Intermodal logistics involves multiple transitions between transport modes, often leading to delays and inconsistent transit times. 5. A company needs to move perishable goods using an intermodal solution that balances speed and cost. Which mode combination is most effective? A. Rail truck. B. Air truck. C. Ocean rail. D. Truck pipeline. Correct answer, B. Explanation. Air truck intermodal transport ensures fast transit for perishable goods while reducing costs compared to direct air freight. 6. Why is intermodal transportation considered environmentally sustainable? A. It reduces reliance on high-emission transport modes. B. It eliminates the need for fuel-based transport. C. It shortens supply chain distances. D. It requires fewer regulatory approvals. Correct answer, A. Explanation. Intermodal transportation optimizes mode selection, reducing emissions by shifting cargo from road to rail or waterborne transport. 7. What is a primary challenge in integrating intermodal transportation across international borders? A. Increased demand variability. B. Regulatory inconsistencies and customs clearance delays. C. Inflexibility in cargo type selection. D. Limited storage facilities in intermodal terminals. Correct answer, B. Explanation. Different regulations, customs clearance procedures, and documentation requirements make cross-border intermodal logistics complex and time-consuming. 8. A logistics provider is considering autonomous freight transport as an alternative to traditional trucking. Which benefit is most significant? A. Increased cargo capacity. B. Reduced driver shortages and labor costs. C. Faster highway speeds. D. More flexibility in intermodal integration. Correct answer, B. Explanation. Autonomous freight transport reduces dependency on drivers, lowers labor costs, and improves efficiency in intermodal logistics. 9. Which emerging alternative transport mode has the potential to significantly reduce transit times for freight? A. Drones. B. Hyperloop. C. Electric trucks. D. Pipelines. Correct answer, B. Explanation. Hyperloop technology has the potential to revolutionize freight transportation by drastically reducing long-haul transit times. 10. In intermodal logistics, what is the primary function of an inland port? A. Connecting multiple transport modes and facilitating cargo transfers. B. Reducing the number of customs clearances required. C. Storing excess inventory from seaports. D. Providing direct-to-consumer. Correct answer, A. Explanation. Inland ports serve as key intermodal hubs, enabling cargo transfers between rail, truck, and barge, reducing congestion at seaports. Let's take a quick break. Now's the perfect time to show some love. Hit that like button, drop a comment, and share this video. Your support keeps us fired up and ready to keep bringing you more awesome content. Section G. Transportation Management. Overview. Transportation management plays a critical role in optimizing supply chain operations by balancing cost control, efficiency, and service levels. Effective transportation management ensures timely deliveries, reduces logistics expenses, and enhances customer satisfaction. Companies use transportation management systems, TMS, to streamline carrier selection, routing, and shipment tracking. Freight consolidation strategies minimize costs, while real-time analytics improve decision-making. Carrier selection and contract negotiations impact freight pricing and service reliability. Risk management strategies mitigate cargo theft, delays, and disruptions. E-commerce growth drives last-mile logistics, increasing demand for expedited shipping. Sustainability initiatives focus on fuel efficiency and emissions reduction. Emerging technologies like AI, IoT, and blockchain enhance transportation visibility, automation, and security. Future trends include autonomous trucks, drone delivery, and hyperloop networks, reshaping logistics. Key topics. 1. Fundamentals of transportation management. Explanation. Transportation management optimizes freight movement by balancing cost, service levels, and efficiency. It involves carrier selection, route planning, and performance tracking to ensure streamlined logistics operations. Real company example. Walmart employs an advanced transportation network, reducing logistics costs while maintaining high service levels through optimized routing and efficient carrier partnerships. Expansion. Businesses use AI-driven analytics, predictive modeling, and real-time tracking to enhance transportation management. Automation improves load planning, while digital freight marketplaces streamline carrier selection, reducing overall costs and improving efficiency. 2. Transportation Management Systems, TMS. Explanation. TMS technology automates carrier selection, shipment tracking, and cost optimization. It provides real-time visibility, ensuring efficient freight movement across supply chains. Real company example. FedEx integrates a TMS to optimize carrier routing, track shipments in real time, and manage freight consolidation, improving overall efficiency. Expansion. Companies leverage cloud-based TMS platforms, AI-powered demand forecasting, and IoT-enabled cargo tracking. Advanced analytics improve decision-making, while blockchain enhances freight transparency and security. 3. Carrier selection and contracting. Explanation. Choosing the right carriers ensures cost-effective, reliable freight movement. Businesses evaluate private fleets for hire carriers and third-party logistics providers, 3PLs, based on performance, cost, and service reliability. Real company example. Schneider National optimizes carrier selection through data-driven analytics, ensuring competitive pricing and high service levels for its logistics network. Expansion. AI-driven performance benchmarking, automated contract management, and digital freight platforms enhance carrier selection. Companies use predictive analytics to optimize rates and reduce transit risks. 4. Freight rate negotiation strategies. Explanation. Freight pricing involves spot rates, contract pricing, and fuel surcharges. Effective negotiation ensures competitive rates while maintaining service quality. Real company example. Amazon negotiates long-term contracts with carriers, securing volume-based discounts and ensuring stable freight costs despite market fluctuations. Expansion. Companies use digital freight marketplaces, AI-powered cost forecasting, and automated bid management tools to improve rate negotiations. Real-time analytics help optimize fuel surcharges and contractual terms. 5. Performance metrics in transportation. Explanation. Key performance indicators, KPIs, measure efficiency, including on-time delivery rates, cost per mile, and service reliability. Performance tracking ensures continuous logistics improvement. Real company example. UPS monitors transportation KPIs through advanced analytics, optimizing fleet performance and reducing transit delays. Expansion. Businesses implement AI-driven performance dashboards, predictive analytics, and machine learning models to enhance efficiency. Automated reporting tools improve carrier accountability and service consistency. 6. Freight consolidation and cost optimization. Explanation. Freight consolidation combines shipments to maximize load capacity, reduce transportation costs, and improve efficiency. LTL and FTL strategies optimize logistics expenses and minimize empty miles. Real company example. DHL implements freight consolidation strategies to optimize truckloads, reducing costs while maintaining service reliability across global logistics networks. Expansion. Businesses use AI-powered load planning, automated route optimization, and digital freight matching platforms to enhance freight consolidation efficiency, reducing transportation expenses. 7. Inbound and outbound transportation planning. Explanation. Coordinating inbound and outbound shipments ensures supply chain synchronization, minimizing delays and reducing inventory holding costs. Real company example. Maersk optimizes inbound and outbound logistics using predictive analytics, ensuring seamless coordination between suppliers and distribution networks. Expansion. Companies integrate AI-driven demand forecasting, real-time shipment tracking, and automated scheduling tools to enhance transportation planning, improving inventory flow and efficiency. 8. Route optimization and load planning. Explanation. AI-driven route selection and load planning enhance efficiency by minimizing travel distances, reducing fuel costs, and improving delivery times. Real company example. J.B. Hunt uses AI-powered route optimization to enhance load balancing, reducing empty miles, and improving fleet efficiency. Expansion. Businesses leverage IoT-enabled GPS tracking, machine learning-based route analytics, and real-time traffic data integration to optimize load planning and delivery schedules. 9. Sustainability in transportation management. Explanation. Sustainable transportation management reduces emissions through fuel-efficient logistics, alternative energy sources, and carbon tracking initiatives. Real company example. Schneider National invests in electric trucks and fuel-efficient routing to minimize its carbon footprint and enhance sustainability in freight operations. Expansion. Companies integrate AI-driven carbon footprint monitoring, automated fuel optimization, and regulatory compliance tools to achieve sustainable transportation management practices. 10. Risk management in transportation. Explanation. Effective risk management strategies mitigate cargo theft, weather disruptions, and transit delays, ensuring reliable transportation operations. Real company example. FedEx implements AI-driven risk assessment models to enhance cargo security and reduce disruptions in global freight networks. Expansion. Businesses use blockchain-secured freight documentation, real-time cargo tracking, and AI-powered predictive analytics to strengthen risk mitigation strategies in transportation management. 11. Global transportation management. Explanation. Managing international logistics requires coordinating multiple carriers, complying with trade regulations, and optimizing cross-border freight operations for cost efficiency. Real company example. DHL Global Forwarding optimizes international transportation by managing customs compliance, trade documentation, and multimodal freight solutions. Expansion. Businesses use AI-driven customs clearance automation, blockchain-enabled trade documentation, and predictive analytics for global freight planning, improving efficiency and reducing regulatory risks. 12. E-commerce and transportation strategies. Explanation. The rise of e-commerce demands rapid fulfillment, last-mile delivery optimization, and flexible logistics solutions to meet customer expectations. Real company example. Amazon Logistics integrates AI-powered delivery route planning, ensuring fast and cost-efficient e-commerce transportation operations. Expansion. Companies invest in drone deliveries, autonomous delivery vehicles, and real-time shipment tracking to optimize last-mile logistics and improve e-commerce fulfillment efficiency. 13. Digital freight marketplaces. Explanation. Digital freight platforms match shippers with carriers in real time, optimizing logistics operations, reducing empty miles, and improving freight visibility. Real company example. Uber Freight connects businesses with available carriers using an AI-driven freight matching system, reducing inefficiencies and lowering costs. Expansion. Companies adopt machine learning-based freight pricing, dynamic load scheduling, and blockchain-enabled contract management to enhance transparency and efficiency in freight brokerage. 14. Technology integration in transportation. Explanation. IoT, blockchain, and AI improve transportation management by enhancing visibility, security, and predictive analytics for logistics operations. Real company example. FedEx integrates blockchain-based shipment tracking, providing real-time transparency and security for global freight movement. Expansion. Businesses implement AI-driven predictive maintenance, IoT-enabled fleet monitoring, and automated warehouse transportation coordination, improving operational efficiency and reducing transit disruptions. 15. Future trends in transportation management. Explanation. Autonomous trucks, drone deliveries, and Hyperloop technology are reshaping logistics, increasing speed, and reducing transportation costs. Real company example. Tesla develops autonomous freight trucks with AI-powered logistics systems, reducing labor costs and enhancing fuel efficiency. Expansion. Companies invest in AI-powered autonomous delivery networks, electric freight vehicles, and Hyperloop cargo transport to drive future transportation efficiency and sustainability. Summary. Global transportation management, e-commerce logistics, and digital freight platforms are transforming supply chain efficiency. AI-driven technology, IoT, and blockchain enhance visibility and automation. Future advancements in autonomous trucking, drone deliveries, and Hyperloop networks will further revolutionize logistics, optimizing speed, cost, and sustainability in transportation management. Let's take a small practice test for Section G. 1. A company wants to reduce freight costs by increasing load efficiency. Which transportation strategy should it prioritize? A. Reducing shipment frequency. B. Implementing freight consolidation. C. Increasing just-in-time deliveries. D. Selecting a more expensive but faster carrier. Correct answer, B. Explanation. Freight consolidation combines multiple shipments into fewer, larger loads, reducing per-unit transport costs. 2. What is the primary advantage of using a transportation management system, TMS, for carrier selection? A. TMS prioritizes cost over service quality. B. TMS ensures 100% on-time delivery. C. TMS provides data-driven carrier evaluation. D. TMS guarantees the lowest rate in all scenarios. Correct answer, C. Explanation. A TMS analyzes cost, performance, and service reliability to optimize carrier selection based on business needs. 3. A logistics manager needs to optimize routes while minimizing fuel consumption and transit time. Which technique should they use? A. Load stacking. B. Dynamic route optimization. C. Freight pooling. D. Post-shipment auditing. Correct answer, B. Explanation. Dynamic route optimization uses real-time data and AI to reduce fuel costs and improve efficiency. 4. A company is negotiating a contract with a carrier for long-term shipments. Which factors should be prioritized to ensure cost efficiency? A. Lowest per mile rate. B. Flexible pricing structure. C. Service reliability and capacity guarantees. D. Carrier brand reputation. Correct answer, C. Explanation. A reliable carrier with guaranteed capacity ensures cost control over time, avoiding fluctuations in rates due to demand surges. 5. How does a digital freight marketplace benefit shippers? A. Increases negotiation complexity. B. Provides real-time load matching. C. Reduces transparency in pricing. D. Limits carrier options. Correct answer, B. Explanation. Digital freight platforms use AI for automated load matching, increasing efficiency and cost transparency. 6. A company's transportation cost per mile is higher than industry standards. What should be the first step in cost optimization? A. Reduce fuel costs. B. Analyze route efficiency and fleet utilization. C. Increase shipment frequency. D. Change all carriers. Correct answer, B. Explanation. Evaluating route optimization and fleet utilization helps identify inefficiencies contributing to high costs. 7. What is a key sustainability strategy in transportation management? A. Using higher-cost carriers with better service. B. Transitioning to alternative fuels and energy-efficient vehicles. C. Prioritizing air freight over trucking. D. Increasing empty backhauls. Correct answer, B. Explanation. Using electric trucks, biofuels, and optimizing fuel efficiency reduces environmental impact and operational costs. 8. A company must comply with international trade regulations when shipping across borders. Which of the following is most critical for smooth operations? A. Selecting the cheapest customs broker. B. Implementing a global trade compliance system. C. Avoiding duties and taxes. D. Relying solely on third-party logistics providers, 3PLs. Correct answer, B. Explanation. A trade compliance system ensures regulatory adherence, reducing customs delays and penalties. 9. A retailer experiencing a surge in e-commerce orders is struggling with last-mile delivery costs. What strategy should they consider first? A. Using a single national carrier. B. Expanding delivery time windows. C. Partnering with local delivery providers. D. Increasing order minimums for free shipping. Correct answer, C. Explanation. Partnering with local couriers optimizes last-mile delivery by reducing transit time and cost. 10. How can AI-driven predictive analytics improve transportation management? A. Eliminating human decision-making in logistics. B. Forecasting demand and optimizing capacity planning. C. Increasing reliance on manual scheduling. D. Reducing the need for transportation contracts. Correct answer, B. Explanation. AI-based analytics predict demand patterns, reducing empty miles and improving shipment planning. Section H. Transportation Administration. Overview. Transportation administration is essential for ensuring compliance, managing documentation, and optimizing financial controls in logistics operations. It encompasses regulatory adherence, freight documentation, and risk management to maintain supply chain efficiency. Companies must comply with national and international transportation laws to prevent legal issues and maintain operational integrity. Freight auditing ensures cost control, while customs and trade compliance streamline cross-border logistics. Risk management strategies mitigate liability, ensuring cargo security and safety. Workforce management optimizes driver performance and regulatory adherence. Technology, such as transportation management systems, TMS, and electronic logging devices, ELDs, improves visibility and efficiency. Data analytics enhance reporting, while sustainability initiatives track emissions and regulatory compliance. Future trends include AI-driven compliance automation and blockchain for secure documentation. Key topics. 1. Fundamentals of Transportation Administration. Explanation. Transportation Administration manages documentation, compliance, and logistics coordination. It ensures efficiency by overseeing legal, financial, and operational aspects of freight management. Real company example. FedEx integrates centralized transportation administration optimizing documentation workflows and regulatory compliance to ensure seamless logistics operations. Expansion. Companies utilize AI-powered administrative platforms, automated freight documentation systems, and real-time compliance tracking to improve efficiency, reduce manual errors, and enhance logistics oversight. 2. Regulatory compliance in transportation. Explanation. Compliance with FMCSA, DOT, ITA, and IMO regulations ensures safe and legal transportation practices, reducing risks and maintaining operational legitimacy. Real company example. UPS adheres to global transportation regulations by implementing automated compliance, tracking, and safety audits, ensuring regulatory adherence. Expansion. Businesses integrate AI-driven regulatory monitoring, automated compliance reporting, and blockchain-based documentation to streamline adherence and reduce non-compliance risks. 3. Documentation in freight management. Explanation. Freight documentation, including bill of lading, BOL, waybills, invoices, and packing lists, ensures cargo tracking, payment processing, and regulatory compliance. Real company example. Maersk digitizes freight documentation, reducing processing errors and improving real-time cargo visibility across global trade routes. Expansion. Companies deploy electronic documentation platforms, AI-powered data validation, and blockchain-secured freight records to enhance accuracy, security, and efficiency in freight administration. 4. Freight auditing and payment processing. Explanation. Freight auditing verifies invoices, preventing overcharges and ensuring cost accuracy. Automated payment processing improves efficiency and financial control. Real company example. DHL uses AI-driven auditing tools to detect invoice discrepancies, reducing financial losses and improving cost transparency in transportation management. Expansion. Companies implement automated payment reconciliation, AI-powered invoice validation, and digital contract management to streamline freight auditing and cost optimization. 5. Customs and trade compliance. Explanation. Trade compliance ensures adherence to customs regulations, including duties, tariffs, and import-export documentation, preventing legal penalties and shipment delays. Real company example. CMA-CGM automates customs clearance, using AI-driven compliance tracking to expedite global freight movement and reduce regulatory risks. Expansion. Businesses integrate automated customs declaration platforms, blockchain-enabled trade documentation, and AI-driven compliance analytics to enhance customs efficiency and prevent regulatory violations. 6. Transportation risk and liability management. Explanation. Effective risk management strategies mitigate cargo theft, damage, and liability exposure. Insurance policies, claims processing, and dispute resolution ensure financial protection. Real company example. Amazon employs AI-driven cargo tracking and real-time security monitoring to prevent theft and ensure loss prevention in its supply chain. Expansion. Companies integrate blockchain-secured cargo tracking, predictive risk analytics, and automated claims processing to enhance transportation risk management and liability mitigation. 7. Safety regulations and enforcement. Explanation. Ensuring compliance with driver regulations, vehicle inspections, and hazardous materials handling laws is critical to transportation safety. Real company example. FedEx implements electronic logging devices, ELDs, to monitor driver hours and ensure compliance with DOT safety regulations. Expansion. Businesses utilize AI-driven fleet safety monitoring, automated compliance reporting, and predictive maintenance to improve adherence to safety regulations and reduce accident risks. 8. Workforce management in transportation. Explanation. Workforce management involves driver scheduling, training, and regulatory compliance tracking to optimize efficiency and safety in transportation operations. Real company example. Schneider National uses AI-powered workforce analytics to optimize driver schedules and improve productivity while ensuring compliance. Expansion. Companies implement automated workforce scheduling tools, real-time performance monitoring, and AI-driven compliance tracking to enhance transportation workforce efficiency. 9. Technology in transportation administration. Explanation. Technologies like transportation management systems, TMS, electronic logging devices, ELDs, and digital freight documentation enhance administrative efficiency and compliance. Real company example. UPS utilizes an advanced TMS to streamline logistics coordination, track shipments, and optimize carrier selection in real time. Expansion. Businesses integrate AI-driven predictive analytics, IoT-enabled fleet tracking, and blockchain-based digital contracts to improve transportation administration efficiency. 10. Data analytics and reporting. Explanation. Data analytics optimize transportation operations by tracking KPIs, analyzing costs, and benchmarking performance across logistics networks. Real company example. J.B. Hunt uses machine learning-based data analytics to enhance routing efficiency and reduce transportation costs. Expansion. Companies leverage AI-powered dashboards, automated reporting tools, and real-time KPI monitoring to improve decision-making and operational efficiency in transportation administration. 11. Disruptions and contingency planning. Explanation. Effective contingency planning mitigates the impact of disruptions such as weather events, strikes, and supply chain interruptions on transportation operations. Real company example. DHL implements AI-driven disruption monitoring and alternative routing strategies to minimize delays caused by extreme weather conditions. Expansion. Companies use predictive analytics, automated contingency planning tools, and AI-driven supply chain risk assessments to enhance transportation resilience and reduce operational disruptions. 12. Sustainability and green compliance. Explanation. Sustainable Transportation Administration focuses on emissions tracking, alternative fuels, and regulatory compliance to minimize environmental impact. Real company example. Maersk invests in carbon-neutral shipping initiatives, leveraging AI-powered fuel efficiency optimization and alternative energy sources. Expansion. Companies deploy AI-driven emissions monitoring, blockchain-secured environmental reporting, and hybrid fleet solutions to improve sustainability compliance in transportation logistics. 13. Security in transportation administration. Explanation. Ensuring cargo security and preventing fraud through digital security measures and physical cargo protection strategies safeguards transportation assets. Real company example. FedEx integrates AI-driven fraud detection systems and real-time cargo tracking to enhance transportation security and prevent theft. Expansion. Businesses implement blockchain for secure cargo documentation, IoT-enabled security monitoring, and automated anomaly detection to strengthen security in transportation administration. 14. Third-party logistics, 3PL, and outsourcing. Explanation. Third-party logistics, 3PL, providers manage freight brokerage, transportation contracts, and distribution networks to optimize supply chain efficiency. Real company example. UPS Supply Chain Solutions provides 3PL services, managing end-to-end transportation operations for global businesses. Expansion. Companies integrate AI-driven 3PL selection tools, real-time performance analytics, and cloud-based contract management platforms to enhance outsourcing efficiency and cost-effectiveness. 15. Future trends in transportation administration. Explanation. Emerging trends in transportation administration include AI-driven compliance automation, blockchain for secure documentation, and predictive analytics for operational efficiency. Real company example. Amazon Logistics integrates AI-powered compliance tracking and blockchain-secure documentation to enhance transparency and automation in transportation operations. Expansion. Companies invest in machine learning-based regulatory compliance, AI-driven administrative workflows, and digital freight marketplaces to improve transportation efficiency and scalability. Summary. Transportation administration continues to evolve with sustainability initiatives, security advancements, and AI-driven compliance automation. Businesses implement predictive disruption planning, blockchain-secured freight documentation, and third-party logistics partnerships to improve efficiency. Future trends focus on automation, digital security, and green compliance, ensuring optimized logistics management and long-term supply chain resilience. Let's take a small practice test for Section H. 1. A logistics company faces frequent customs delays due to incorrect documentation. Which action is most effective for improving compliance? A. Hire a customs broker for all shipments. B. Implement an automated trade compliance system. C. Increase manual checks before shipment. D. Reduce the number of international shipments. Correct answer, B. Explanation. Automated trade compliance systems ensure that documentation meets international regulations, reducing delays. 2. A transportation manager must select a carrier that complies with FMCSA safety standards. Which factor is most relevant? A. Carrier's safety rating in the DOT database. B. Carrier's lowest freight cost. C. Carrier's total fleet size. D. Carrier's years in operation. Correct answer, A. Explanation. FMCSA safety ratings ensure that a carrier meets required safety and regulatory standards. 3. A company notices discrepancies between freight invoices and actual shipments. What is the most efficient method to resolve this? A. Conduct manual freight audits weekly. B. Implement an automated freight auditing system. C. Outsource all freight auditing to third-party auditors. D. Accept minor discrepancies as unavoidable. Correct answer, B. Explanation. Automated freight auditing reduces manual errors and ensures accurate reconciliation of invoices. 4. A shipment of hazardous materials requires compliance with DOT and IMO regulations. Which document is most essential for international transport? A. Standard Bill of Lading, BOL. B. Dangerous Goods Declaration. C. Commercial Invoice. D. Packing List. Correct answer, B. Explanation. The Dangerous Goods Declaration ensures compliance with hazardous material handling regulations. 5. A company wants to improve workforce efficiency in transportation administration. Which strategy is most effective? A. Increase driver working hours beyond legal limits. B. Implement a driver scheduling system that tracks hours of service, HOS, compliance. C. Hire more drivers without optimizing scheduling. D. Reduce required safety checks to save time. Correct answer, B. Explanation. HOS tracking ensures compliance while optimizing driver efficiency and scheduling. 6. A company wants to reduce cargo theft in transit. Which measure is most effective? A. Relying on driver-reported security incidents. B. Implementing real-time cargo tracking with geofencing alerts. C. Avoiding high-theft areas without monitoring. D. Increasing insurance coverage without preventive measures. Correct answer, B. Explanation. Cargo tracking with geofencing enhances security by detecting unauthorized route deviations. 7. A logistics company must comply with ITA air cargo regulations. Which factor is most critical for regulatory adherence? A. Ensuring the cargo is packed efficiently. B. Verifying proper classification and labeling of air shipments. C. Selecting the fastest air carrier. D. Reducing air cargo weight for cost savings. Correct answer, B. Explanation. Proper classification and labeling ensure compliance with IATA regulations for air cargo safety. 8. A company aims to enhance sustainability in transportation administration. Which strategy is most impactful? A. Increasing truck fleet size to reduce delays. B. Switching to electric or fuel-efficient vehicles. C. Prioritizing air freight for speed. D. Reducing regulatory compliance efforts. Correct answer, B. Explanation. Fuel-efficient and electric vehicles significantly lower carbon emissions in transportation. 9. A logistics firm faces frequent supply chain disruptions due to extreme weather. Which strategy would best mitigate risk? A. Relying on a single transportation route. B. Developing contingency plans and alternative routes. C. Reducing international shipments. D. Ignoring disruptions and focusing on cost savings. Correct answer, B. Explanation. Alternative routes and contingency planning improve supply chain resilience against disruptions. 10. A logistics firm wants to adopt blockchain for transportation administration. What is the biggest advantage? A. Reduce transportation costs. B. Enhance transparency and security in freight documentation. C. Increased reliance on manual documentation processes. D. Decreased need for compliance tracking. Correct answer, B. Explanation. Blockchain ensures secure, transparent, and tamper-proof freight documentation, improving regulatory compliance. Thanks so much for sticking with me until the end. I'm really glad to have you here. Don't forget to check the description below for links to all the study materials. You'll find everything you need to succeed. Also, be sure to watch the previous modules in the CLTD playlist and stay tuned for the next one. If you found this helpful, please like, comment, share, and subscribe to the channel. It really helps support the content and brings more valuable resources your way. Until next time, keep up the great work, and I'll see you in the next module.